Hello, my name is Lily and I'm a former student of Dr. D's. Today I'll be showing you how to double interpolate.
It is first good to note you will be primarily double interpolating with the superheated and compressed tables for this class. Recall that you need any two intensive properties to define a state, and with these tables, temperature and pressure are independent of each other. For our example today, our intensive properties will be temperature at 180 degrees Celsius and pressure equaling 0.2 bar. We want to find the enthalpy from looking at our given intensive properties. We first need to determine our state. In this instance, from looking at our intensive properties, we can determine that we have a superheated water vapor. Next, we identify the need for double interpolation. We'll notice neither the given temperature nor pressure values fall kindly onto the table. We will have to interpolate with respect to both properties. In this example, I will interpolate with respect to temperature first. If we were to plot temperature and enthalpy at pressure equaling 0.06 bar and estimate our enthalpy with our given temperature, it would look something like this with regular linear interpolation. Hopefully, you're already comfortable with regular linear interpolation. If not, Dr. D has another really great video on it. Anyways, here's what the math would look like. From this, we'll see that our enthalpy at 180 degrees Celsius and 0.06 bar is equal to 2,841.1 kilojoules per kilogram. And now, if we linear interpolate, still at temperature equaling 180 degrees Celsius, but this time at pressure equaling 0.35 bar, the math will look like this. With this, we'll find our enthalpy estimated at 180 degrees Celsius and 0.35 bar equals around 2,839.5 kilojoules per kilogram. Now, we can fill in the gaps of our table with our newfound values. After interpolating with respect to our given temperature and have found our respective enthalpies at both pressure equaling 0.06 bar and 0.35 bar, we can now interpolate with respect to pressure at 0.2 bar. You'll notice the approximations from prior represented as red stars. Now that we have our enthalpy values at the correct temperatures, we can interpolate with respect to pressure using the approximations. Our math, as we interpolate with respect to pressure now, with the two values at the right temperature, will look like this. The math calculates to 2,840.33 kilojoules per kilogram, which, recall, is our enthalpy at 180 degrees Celsius and 0.2 bar. That is our final answer, and here is where it would go on the table. It is good to note that it would be equally correct to interpolate with respect to pressure first. In this instance, you would interpolate for enthalpy at the two separate temperatures with respect to pressure, and then interpolate with respect to our given temperature for your answer. It may yield a slightly different answer, but both methodologies are correct. And that concludes our video on double interpolation. Thank you so much for watching.